if 1200 Na plus ions flow across a cell membrane in 3.5 microseconds. The charge on the sodium is the same as on an electron, but positive. So the first thing you always want to do when you do these problems is write down what we're given. So basically in this problem, we're given a time, right, a change in time, which in this case is 3.5 microseconds. So we have that. And they also give us charge. So they tell us you're having 1200 Na plus ions, right? So that's basically going to be our charge. And then what we're solving for is the current, right? So we can just write I equals question mark. How are we going to find I given charge and time? So you basically need to know what current is. So current is defined as the change in charge over the change in time. So they tell us, right, so just we know 3.5 microseconds is our change in time because that's our span, right? So we're finding how much, right, what is the current in amperes that flow across in this amount of time. So we have, this is our change in time, but then how do we get the charge? And so we want to find it in amperes, right? So we want to find it in amps, and you need to know that amps are written as coulombs per second. So when we write this, we have to convert this unit, and then we have to find the charge of this many Na plus ions. So let's go ahead and do that. So starting off on the bottom, it's just easier. So we need the time in seconds. So 3.5 microseconds is equal to 3.5 times 10 to the minus 6 seconds. You should just know that by now. So that's going to be the change in time. And now we got to find the change in the charge. So they tell us 1200 Na plus ions. But they tell us that the charge on the sodium is the same as on an electron, but positive. So the charge of an electron, that's just a value you need to know, right? So one electron, the charge is 1.6 times 10 to the minus 19 coulombs, right? So usually it's negative, but in this case, they're saying it's positive. So if we have 1200 of these and they each have a charge of this, to convert, we just got to multiply. So you can just put it on top. Actually, yeah. So let me do it on the bottom here. So we have 1200 Na plus ions, right? And for every one of these ions, and one Na plus ion, we have this charge, right? Because they're equal. Because one of these is equal to an electron, and then an electron has that charge. So basically, that's going to allow us to convert to coulombs. So you're just going to do 1200 times this value. 1200 times 1.6 times 10 to the minus 19. Yeah. So you're going to get, and I'm just going to write it here, 1.92 times 10 to the minus 16. And so now we have coulombs, and we have seconds over it, so you can just divide, and that's going to give us your current. So go ahead and plug that in. So we're going to have the current is equal to, we divide here, 3.5 times 10 to the minus 6. Yeah, so you're going to get I equals 5.4, and I'm just going to round it to 5.49 times 10 to the minus 11 amps. So 5.49, yeah, 5.49 times 10 to the minus 11 amps. That's going to go ahead and be your answer. And yeah, hopefully you found this useful.